I have absolutely nothing to say whatsoever. And yet I will make it seem like I do.
B2B services
and operating excellence.
A headcount that you need to be considered a disruptor in your marketplace
is an ownership stake in an underlying network.
It had a very leveraged effect.
Welcome aboard the Dejargonizer Flight 101 to the moon. I'm your captain, Amir Mizrach. Our navigator today is Alice Miller, Vice President of Space at a company called Helios. Helios is working on humankind's next chapter: commercial space exploration, moon and Mars colonies, and off-world mining. Listen closely as we piece together this journey through space and time.
It's difficult but simple, okay?
But why, some say, the moon? We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. But we shall send to the moon 240,000 miles away from the control station in Houston, a giant rocket carrying all the equipment needed for propulsion, guidance, control, communications, food, and survival on an untried mission to an unknown celestial body, and then return it safely to Earth.
Hi, Alice. Thanks for being on the Dejargonizer.
Hi, Amil. Thanks a lot for inviting me.
When it comes to space, I feel like for a lot of people, and definitely me included, space sparks joy.
Yes.
Sparks my imagination. It sparks my childhood. It sparks what I think about my children and the world that they're going to grow into and the things that they will see.
Yeah.
And I want to make sure that as we're talking about space tech and there's a new space industry where it's not just governments, it's not just Bezos and Musk, it's also companies that are all across the value chain. And I want to try and tell that story through Helios. So tell me about Helios.
So Helios is an Israeli startup. We have been here for 5 years now. We have 27 employees. Generally speaking, we started off as a space company with a mission to produce oxygen out of regolith on the moon. Regolith is the lunar soil.
What's it called?
Regolith, R-E-G-O-L-I-T-H, regolith.
Who gave it that name? It's like a weird
God
name.
knows. Yeah, okay. I don't know.
Okay.
Good question, but everybody knows that's what it's called today, which is actually the dust on the moon, which is very, very similar to many rocks that we have here on Earth.
Moon dust.
It's moon dust, yeah. It's really dusty and problematic. It's got a lot of problems. It's very electrostatic. It sticks to everything. It's very abrasive. It ruins everything. It's quite harsh over there. We were developing technology to produce oxygen on the lunar surface, which is going to be a necessity for the human race to be able to move around in what's called cislunar space, which is the area between Earth and the moon, including the moon's surface, and beyond, of course, Mars and whatnot. The first stage is making rapidly reusable rockets. Once we can leave the Earth's atmosphere, the second stage is providing propellant in space. Without this propellant, rockets will not be able to reach the moon and carry on flying around the moon. So it is a strategic need.
How does that even begin? You need to go out there. Have you tried on space? Do you know that this works on moon dust?
So I just want to say that in moon dust, by lots of research that has been done with samples that have come back from Apollo in the 70s.
So there's a foot on the moon, stepping down on the moon. Armstrong is on the moon, Neil Armstrong.
Although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. I can pick it up loosely with my toe. It does adhere in fine layers, like powdered charcoal, to the sole and sides of my boot.
They found that moon dust has about 40% oxygen, okay, which is true actually to any rock on any place. Rocks are made up out of metals, and minerals, and it's actually metals which are totally bound to oxygen. So you get like iron oxide, silicon oxide, all kinds of oxides. And 40% of the moon dust is oxygen.
Hold on, I just want to make sure I understand, because the last time I did this, I was 15. Oxide just means that it has oxygen in it. It could be uranium oxide.
Exactly.
Got it.
Exactly. I don't know about uranium oxide. I'm not a chemist myself, but I know that iron oxide, which is rust, is actually oxygen and iron bound together.
So you know this works because they brought back lunar dust on the Apollo and potentially aliens. And then you know this works and you have a plant or some sort of, factory to make it. Can you tell me how you do it?
We have a lot of research done on the regolith brought back by the Apollo missions. But of course, nobody can touch that regolith. It's closed up in vaults in NASA somewhere, and you can't really get to that. So what we have on Earth is something called simulants, regolith simulants, which are lab-made concoctions of all kinds of oxides put together, made in a specific way that simulate the physical and chemical properties of lunar regolith. This simulant you can buy from many labs around the world. Costs $30 a kg. Anybody can buy it.
So this is like fake moon dust.
Fake moon dust, exactly.
Synthetic moon dust.
Yes, to put it that way. Yeah.
And something else that you said was interesting, just want to go back. You said that the real moon dust is kind of locked in a NASA lab somewhere?
Yeah, in vaults in NASA.
Why?
I don't know exactly why. I'm sure they want to do research on this moon dust. We don't have a lot of it. They brought back about 400 kilos of this stuff, and when they came back from the Apollo missions, and part of it has been dished out to research facilities. They keep it in very, very extremely sterile conditions because on the moon there's no oxygen, so you don't want to expose this to oxygen. It might change its properties, etc. I really have no idea.
This is the beginning of like a space horror movie. Anyway, sorry, let's go back.
But the simulants we use are very close to what happens on the moon. What we do is we take this simulant, we heat it up to a very, very high temperature in which it starts to become molten. It actually melts. It comes into this type of lava. And then we electrolyze it. We put electricity into the mixture and we actually force the oxygen to separate from its metals. Done our lab POC, proof of concept, and we're moving on to building a larger scale, like industrial scale system.
And is that eventually this reactor you're hoping to place on the moon to create this? That's the vision. How long do you think that will take?
Well, in 2025, we're going to the lunar surface with a lunar lander with a Japanese company called iSpace. They're taking us there, and we're going to take a few grams of regolith, and for the first time in the history of humanity, produce oxygen out of regolith on the lunar surface. But this is just out of a few grams, yeah? The second system we want to put is going to be a continuous system, where on one side you have a conveyor belt putting regolith into the system continuously. Then we will have a continuous production system, and on the other end we'll have a liquidation system, turning the oxygen into liquid oxygen, and that will be supplied to lunar landers on the moon. It will be supplied to the human habitat, and hopefully the system will be on the moon around 2028, 2029.
How much of the regolith do you need to make oxygen?
A lot. If the regolith has 40% oxygen, from every ton of regolith, we can make 400 kilos of oxygen.
Okay, I'm going to ask a left field question here. When I look at the space race and the moon race, the race to the moon part 2, it's unclear to me under which auspices will your reactor work? Who's going to protect it? Is it on the western side or the eastern side? Who do you call if and when something goes wrong? How do you maintenance?
I have no idea. Listen, it's a very big mess up there. There are all kinds of treaties that are written between governments. I don't think anybody in the Western world over here has a treaty with China that China signed on. Our goal in the end is to produce 1,000 tons of oxygen on the moon in 2032.
So 1,000 tons of oxygen, is that enough for, I don't know, how many refuelings?
1 Starship a month. Plus, we have a fantastic thing that happened to us here at Helios, which is our terrestrial application. We have a terrestrial application which turns out to be really fundamental in our capability to fund our next 10 or 12 years coming up.
So when you say terrestrial applications, you mean to make oxygen on Earth for Earth?
Nope, because making oxygen on Earth for Earth,
it's a stupid question, right?
People know how to do it. No. I'm talking about something totally different. We were doing an experiment here in one of our furnaces, and we put some regolith into the simulant into one of these ovens. When we produce oxygen, we get iron as a byproduct. Every time we did the experiment, we found that we produce more iron than is available in the regolith itself. So we broke down the furnace again and again and again and tried to understand how is this happening. And what we found is that actually the whole oven was coated with some iron oxide in the inside, and something in the oven was actually attacking this iron oxide and separating the oxygen from the iron. And then one of our engineers here said, maybe instead of producing oxygen and getting iron as a byproduct, we can produce iron and get oxygen as a byproduct. Today, the steel industry is the second largest polluter on Earth. About 10% of CO2 emissions are from the steel industry. And why do we get CO2 pollution? Because you take coal, you take iron ore, you mix the two together, you get carbon dioxide and you get iron. In the technology we developed here, we have managed to produce pure iron while releasing only oxygen. This terrestrial application that we stumbled upon is going to, on one hand, eliminate something like 1.7 trillion tons of carbon dioxide a year. And second thing it's going to do is it's going to be a fantastic way for us to fund our space development in order to reach our goal of 2033.
The company's been around for 5 years. What are the challenges for you as head of space?
Endless challenges. First of all, there's technological challenges, number one. It's a very, very tough technology to develop. We're working with molten rocks in a very highly corrosive, oxygen-rich environment. The crucible melts, the electrodes melt. Another thing which is very challenging, not only for me, but for any company that's doing anything on the moon. Today, the cost of putting anything on the moon is $1 million per kilo. $1 million per kilo. That means that if we want to do an experiment on the moon, even before we do any R&D, any research, any development, anything, we have to pay a few $1 million just to get our payload there. It's very hard to get people to invest in space projects that are going to be ripe in 10, 15 years' time.
It sounds like you're a space infrastructure company, a space propellant maker.
That's very true. If you really look deep into the future, there is going to be a lot of movement up there. But undoubtedly, controlling the oxygen production on the lunar surface can be extremely lucrative 10, 15 years downstream.
I guess Helios is kind of the BP, the Shell of the space age.
Well, right now, Helios is a startup with 27 workers. We have a bit of way to go. But yes, somebody is going to have to make this happen.
Well, I was hoping that you would say that, you're a true believer and you believe Musk when he says we need to become a multi-planetary species.
I think it's more like unstoppable human exploration bug, that you just can't stop. Or sometimes you really want to understand why you're doing what you're doing, and it's even hard to explain to yourself why you're doing what you're doing, When you lie down under the stars, you just look up, everything is so beautiful. You really want to know, what it's all about and what's over there and what's beyond what's over there. And you really want to check it out and see if it's possible and go there and do it. Can't stop that natural feeling that we have.
And I couldn't think of a better vibe and definition of what a VP space is. I loved having you on. Alice Miller, VP Space at Helios. Thank you very, very much for being on the show.
Pleasure. Thank you very much. I hope I didn't make it too complicated because, it is complicated.
The Israel-based startup wants to be the BP, or Shell, of the new space age. They want to build a network of liquid oxygen production and distribution assets on the moon. They want to serve that whole next phase of humankind's journey into the stars. Or at least one starship a month, somewhere around 2033, about 10 years from now. How does that sound? But what do you think? Let me know by leaving a review or comment on your favorite podcast app or on Substack at thedejargonizer.substack.com. The Dejargonizer is produced and edited by Astrid Landon.